right now, and then we can get a hint.
All right, here we go. Welcome to the YouTube channel again. All right, just make sure you like and subscribe, and merch will pop up halfway through on the ad that you won't actually see. All right, ready? Just kidding. All right, so 2 assignments today. Scale functions vertically and scale functions horizontally. It's going to look like that, people. Okay? So what does this mean, scale? So let's go to Desmos. Let's do this right now, everybody. Let's graph some stuff. Here's how I'm going to graph. Let's do x squared, okay? The old parabola, our friend. Good old reliable parabola. Very similar to Tesla and Bitcoin stock price right now, right? Parabolic. See that thing? It's crazy, right? Woo! Nuts. Going straight up. Ready? Here we go. Now, if I want to make this thing bigger in any way, shape, or form, or stretch it out somehow, I can't just add and subtract like we did earlier in the week, right, where we shifted stuff. If I can't add and subtract, what do you think I could do in order to stretch it out? Multiply. Hey, nice guess. So, for example here, this is one example. All right, so what I just did was I multiplied the original function by 4. Right, and you can mess with it, toy with it, whatever you want to do. I stretched it out. So it's like I took these two parts here, these two, and I pulled them straight up, right? And as I pull them up, it's like a rubber band, right? You pull a rubber band up, what happens to the rubber bands? They get closer together, right? If you pull up the loop, that's what would happen. So if I multiply, it stretches it out and makes it look taller, okay? Another way to see this is here. So let's take something like this. Let's shift it over. Let's do something a little different. Let's do 5x squared. I'm just going to make one up. Plus 2x plus 1. And if I want to multiply this one, I can't just multiply one of the numbers. What do I have to multiply? All of them, right? So let's say I want to stretch this thing out times 2. I want to double it. That means I have to double every number. Every term, I've got to change it to 10x squared, 4x plus 2, right? I've stretched it out. If we zoom in here, you're going to have to do questions kind of like this. The original point, the original vertex was down here. It was at a height of 0.8. Right? If you click on your first little graph there, right on the vertex, it'll give you the coordinates. The original vertex is at 0.8. After I doubled it, where's the new vertex? 1.6, right? It doubled it. That's the effect, and you can see it in the graph. So what you're going to be asked to do today is not actually graph like this, but you're going to have to tell me, or tell Khan, what was the new equation, or what is the effect? What did they do? Right? Now, what I've talked about is just stretching it out. So that means growing it, right? So the opposite of that would be a shrink of some kind. So how do we do that? All right, you think we would divide. So instead of divide, let's think of it like we're multiplying by a fraction. All right, so here's our original x squared. Let's, instead of pulling it and making it tighter and making it taller, let's widen it out. So let's do like 1/4 and then x squared. All right, now we have flattened it. It's like we put our hand on the top of the parabola down here and we smashed it down. I'm trying to think of an example of something like that, like a paper bowl or something like that. You just, or a cup, right? And smash on it, right? We have now widened it out. It looks wider, but it's really just shrunk. So it's hard to tell when they're both on 0, 0. So let's go to an example again like this one. Throw in some numbers here. 2x squared plus 4x plus 8. I have to zoom back out to find this one. All right, there it is. Now what I'm going to do, 2x squared plus 4x plus 8, I'm going to flatten it out. I'm going to shrink it. And let's do it by a factor of a half. So let's multiply each one of these numbers by a half. So that would turn the first one into x squared, second one into 2x, and the last term into 4. And we can see that the height of the vertex is exactly half, right? The vertex of the original is there at negative 1.6, right? The new one that we flattened out has been pushed down, negative 1.3. So if I asked you, hey, what happened from here on my computer, the green one to the black one, what happened from there to there? It got cut in half. Okay. It got scaled vertically. It was just scaled by a half. Let's do a couple from Khan here. All right, so follow along with me. Let me zoom in here a little bit. This is the graph of function f. It says function g is defined as 3 times the function. Notice how it's written on the outside, right? Just like when we vertical shifted, we added and subtracted on the outside of the parentheses. So if this graph is supposed to be 3 times, that means it's going to be 3 times taller. Every point will be 3 times higher. So this point here will now be 3 times higher. So Gary, where's that going to be? Since now it's at 4 and it's supposed to be 3 times higher, where's it supposed to be? 12. Yeah, there you go. And this one was at 2, a height of 2. So now it's going to be at 6, right? This is at a height of 1, so now it's going to be up here at 3. So now we've got a new curve. It's going to look something like that. I'm going to take each one of the points that I can find and multiply it by whatever they ask us to. And then there'll be multiple choice down here in that way. Some of them will be kind of close. Some will not be, right? Look like A was correct, right? 12, 6, and 3 right there. Okay, straightforward enough. Questions? Let's do another one. Different one than this. Oh, hey, there you go. Let's try this one. It says, what is the equation of G? What is it? What is the equation of G in terms of F? So if we started at F, which had a point at 6, and now it's at 2, when I go from 6 to 2, what do I multiply by? You thinking divide in your head, right? You're thinking, oh, you divide by 3. So how can we express that? Yeah, so this is like times 1/3. Very good. All right, so even though it's divided by 3, we have to express it as a fraction. Okay, same thing here. This went from 3 down to 1, and I'm looking at the y coordinates here because we're scaling vertically. All right, so what I need is that. All right, it's 1/3 the size of F. It's not shifted down or anything like that. That would be C and D. We already did that assignment, right? What would this one be? What was B? Yeah, be 3 times larger, right? Which it's not. All right, so that's scaled vertically. If we do move on to horizontally, it's the same kind of idea. Let's do some on Desmos here. Let's do this. It's going to be freaking awesome. Are you ready? Here's, let's do this one. X squared plus 2x plus 4, like that. X squared plus 2x plus 4. Now, watch what happens if wherever there's an x in the equation, we're going to place it, we're going to call it 2x squared. We're going to leave everything else the same. In the middle, instead of saying 2x, it would become 4x, right? And the last part doesn't change. I'm not changing the whole equation like I did before. I'm only changing what's in the parentheses. I'm only changing what's x. So if we look at this, it's very funky looking, but this is a horizontal scale. Here's what has happened. Our original was here in red. The vertex was at negative 1, 3. The new vertex is at negative 0.5. What happened when it moved from there to there, right? This one is at negative 1, 3. This is at negative 0.5, 3. The only movement happened this way, right? There's a horizontal shrink, wasn't it? Right? So why did it do that, though? Remember, I took all the x's, wherever there's an x squared, I replaced it with 2x. If you remember the other day, I said something about what happens in the parentheses. What do we call that place? We call it opposite land, don't we? And I hinted at this sort of thing very briefly. If we replace x with parentheses and make it 2x, it actually means the graph is smaller or bigger? Smaller, right? We shrunk it down. It's a horizontal shrink when we see 2x. So 2x in parentheses, replacing the x actually means it's going to shrink. What does it mean then? What if I replaced every x with this? Yeah, it would grow, right? It'd be a stretch. Each of these I'm talking about are horizontal shrink and a horizontal growth. All right, so if I wanted to do the same thing to the, do a different thing to the same graph, if I change this to 0.5, and I change this to just 1x because it was originally 2, but I don't change the constant. I don't want to do that. I'm just changing the x here. Notice it's larger now. It stretched it out. It was at negative 1, 3. Now it's at negative 2, 3. It stretched it out this way. It hasn't shifted it. If we zoom out, a shift would mean the size and shape are the same. The size is definitely not the same, right? It's not a shift. It's been stretched out. So if we do some of these on con here, let's go. Remember, this is opposite land. So when I see half x in parentheses, it does not mean a shrink. It actually means it grows, right? It grows by factor of 2. So if I see a point here that has an x coordinate of 2, the new x coordinate will be, it'll be 4. And if the original x coordinate over here was negative 2, where will it be now? Negative 4. So our graph will look kind of funky. It'll look something like this. Oh man, that was bad. I'm sorry. Let me try that over. Something like that. Let's find it. Hey, there it is, right? They tried tricking us with this one, didn't they? Right? They wanted us to cut every x coordinate in half. You have to remember this. Horizontal stretches get confusing because it's the opposite of what you think. Just like our horizontal shifts were the opposite. So if you can group them together in your head that way, you'll be fine. Here's another example. This is saying x is now divided by 3 when originally it was just x. Ignore the equation of the graph. It doesn't matter, right? If we look at this, it should be stretched out, right? If it says x over 3, that actually means growth, right? Should grow by 3. So this point is at 3. Now it should be at 9. It was at 1. Now it should be at 3. There we are. Should have the same y coordinates too. Make sure you don't screw that up. All right. I did one of these earlier and I did that. All right, last one, and I'll leave you alone. Function G is horizontally scaled version of f. So f was the beginning. Tell me how did it get to G? What happened horizontally? Well, right now, this is at an x-coordinate of 4, right here. The new x-coordinate is 2, right? So if it went from 4 to 2, that's a shrink. And remember, we're talking about opposite land here, right? So it's almost like when you do these, it helps to work backwards. If I go backwards, what do I have to do? Times 2. So I should be looking for an expression that looks like that. There it is. Okay, so vertical stretches and vertical shrinks look like what they are in the equation. Horizontal ones are the opposite. All right, I'll leave you alone now. Make sure you like and subscribe. Go to MrAMath.com for the merch. 50% off running through 2073.